All right, so we talked about quadratics in your standard form. Well, there's a couple other forms of quadratic functions, one of which is the vertex form and the other's the intercept form. Okay, so the a value in both of those also tells you if you open up or down. So if a is positive, a is greater than 0, you open up. If a is negative, a is less than 0, you open down. Okay, so let's do one here in this vertex form. The vertex form is real nice because it shows you um, where your vertex is. Okay, so here's my vertex form. And so my vertex is at the point HK, which in this case, it's X minus H. Okay, so H has got to be the 3 right there. 3, comma. And then the K is got to be, this is kind of like a plus and negative 2 right here. So K, you bring along that sign in that case. 3, negative 2. Okay, so you put that vertex on there. 3, negative 2. Okay. So number 1, we also know that A is 2, so it's positive. I should have wrote this. This opens up, right? Opens up. So from that point, this thing's going to open up. The vertex, so this will be our minimum here. You got this 3, negative 2. Okay, and then from there, we're going to do the same thing. We know our axis of symmetry is on that vertex, right? So the axis of symmetry is at x equals 3. Better write that. Axis of symmetry is right on the vertex. X equals 3. Alright, so from this vertex, we're going to pick a couple points to the right of 3, so 4 and 5. Pick a couple points to the left of the 3, so 2 and then 1. This should work out. And then we're just plugging it in to your equation. Plug in chug, so we're plugging in 4. 4 minus 3 is 1. 1 squared is 1. 2 minus 2 is 0. So 4, 0. 4, 0. Plug in 5. Right here, 5 minus 3, 2. 2 squared, 4. 4 times the 2 in front, 8. 8 minus 2, we got 6. So 5, 6. Okay. You plug in the 2, and you end up getting 0. You plug in the 1. You get the 1 here, minus 3. Negative 2 squared is 4. 4 times the 2 in front, 8. 8 minus 2. And you already know that you're going to get the same 6 right there. Okay. So 1, 2, 0. And now you got your parabola. So draw that. Oops, U shape there. Okay, there's your vertex. Your lowest point in that case because it opens up. Okay. Let's do another one. How about this one? Y equals A, x minus h quantity squared plus k. All right. Number 1, you notice that your A is that negative 1 in front of the parenthesis there, right? So A is negative 1. So A is negative. This thing's going to open down. Opens down. Now we go to our vertex. Our vertex is HK. Now careful on this sign. You notice it's x minus the h, okay? But up here it's x plus. So let me rewrite this as x minus a negative 1. Isn't x minus a negative 1 the same thing as x plus 1? Negative times a negative there. So you notice your h value is got to be actually negative 1. Your h is negative 1. Okay, and then your k is that 3 right there. So vertex is at the point negative 1, 3. Okay. Now from that point, your axis of symmetry is right on the vertex. So x equals negative 1. It's right on this vertex. X equals negative 1. Whoops, that's a pretty crooked line there. Then we start plotting points again. So we put our vertex on, negative 1, 3. Pick a couple to the right of the vertex. So to the right of negative 1 would be 0, and then a 1. To the left of negative 1, negative 2, negative 3. And then we start plugging that thing in. Okay, so let's plug in 0. Do the 1 squared first. 1 squared is 1. Negative 1 plus 3 is 2. Plug the 1 in now. 1 plus 1, 2. 2 squared, 4. Then they apply the negative in front. So you got negative 4 plus 3, negative 1. And so on. Okay, plug those points in as well. 0, 2, 1, negative 1. 0, 2, 1, negative 1. Plug those ones on there. And soon enough, you see how this thing, whoops, totally missed that dot right there. But anyways, you get the idea. Okay, so that's a vertex form, a very handy form. And when you're looking at these things, you notice that this thing, your original y equals x squared, if you remember the very first graph in that last video, looked like this, right? Well, if you notice, it flipped it over. So that thing is a reflection about the y-axis, so flips it over. And then the plus 1 is going to move it left 1, and then that plus 3 actually moves it up 3. Okay, so that's called a transformation. We'll talk more about that later in the course. Okay, let's go to another form now. This is the intercept form, okay? The intercept form, because it's really easy to find your x-intercepts when you're doing this, okay? So let me write the a x minus p x minus q, okay? That's how we're going to look at this thing, is this is in intercept form, okay? Now your a in front there, a is 1. So a is still positive, opens up. Now, second thing is I'm going to find my x-intercepts. Well, to find my x-intercepts, I always let y be 0. And then I'm just going to solve this. Okay? So if x minus 3 is 0, that would be 0 times whatever. And this would be true, right? You'd have 0. So I'm going to apply the 0 product property here. So either x minus 3 has to be 0, since these two are being multiplied, or maybe this x minus 1 has to be 0, or both, right? So x can be 3. That would make that equation true if I solve that, and then I solve this one over here, x can be 1. So 1 and 3 are my x-intercepts. 1 and 3. Those are my x-intercepts, okay? Now, since this thing is reflective, my axis of symmetry will be right between them. Axis of symmetry between the x-intercepts. Okay, so you know how on these x-intercepts I'm like, well, there's 2 between them, right? So 2 divided by 2 is 1. So if I go over 1 from this, that's splitting it, right? It's going to be right there at an x value of 2. So axis is at x value of 2, x equals 2. Well, that helps me because now I know that's where my vertex lies. My vertex must be on that line, 2, and I just plug it into this. I get 2, negative 1. There it is, right? I already got these 2 points, so there's a couple I already have. To the right, that vertex is 3. I knew that one already, so I need to go one more to the right. To the left of an x value of 2 would be 1 and then 0, and I already know the 1 has that x-intercept. So I plug 4 in now. 4 minus 3 is 1. 4 minus 1 is 3. So I got 3 here, and then 0, 3. Okay. Go back up here. 4, 3. 0, 3. Now I can draw that thing. Okay, so find your x-intercepts by letting y be 0. Your axis of symmetry will split it, and then plot a couple more points if you need them. Okay, let's do it again. Alright, so number 1, you notice that your a is negative 2. So this thing's going to open down. Find your x-intercepts again. So find the x-intercepts by letting y be 0. Okay, take each factor that has an x in it, so that x plus 5 must be 0, or the x minus 1 must be 0 by the zero product proper. Subtract 5 both sides here, add 1 both sides here. Okay, so negative 5 and 1. Negative 5 and 1. Oops, try this a little better here. Those are my x-intercepts, right? Now I know the axis of symmetry splits those. It's right in the middle of those. So I'm like, well, how far is between this? Well, let me count it. 1, 2, 3, 4, 5, 6, right? So it's got to be half of 6 is 3. So 1, 2, 3. Okay, right there. Right there. Looks like that's negative 2. X equals negative 2. Negative 5 plus 2, right? If you go over to the right 2 there. Okay, so x value of negative 2. That's where my vertex is going to be. Negative 2, that's where my vertex lies. I plug that thing in. Looks like we got y equals 18. Okay, let me go by 2's. 2, 4, 6, 8, 10, 12, 14, 16, 18. Sorry, I'm running out of room here. I have 18. Plug some points in, and you see that it's going to look. Oops, I missed my thing, but anyways, plug some points in, you'll see that's what it looks like. It thing opens down. Okay, so that's your intercept form. A couple examples of that. Now, what if you're just supposed to write this thing in standard form? Well, just go ahead and you foil it. So let's foil, first, outer, inner, last, as you recall, right? So I go x times x right there, x squared. Now the outer, x times a positive 3x. Now my inner right here, negative 2 times x minus 2x. And finally a negative 2 times a negative 3 minus 6. Combine any like terms you got and distribute at the end. And you notice, you're like, oh yeah, that's in the old standard form, ax squared plus bx plus c, where a is 2, b is 2, and c is negative 6, okay? All right, let's do one last one. How about the quadratic in real life? Projectile here. We got a path of a ball after you kicked it can be modeled by this, negative 0.1x squared plus 4x. Okay, negative 0.1x squared plus 4, oops, that's an ugly 4, 4x. And there's no c value, if you will. So you see how this is in standard form here. Okay, x is the horizontal distance of feet, y is the height in feet of the ball. What was the height of the ball at its highest point? Okay, you say, well, I know, first of all, you notice how your A is negative 0.1. So this thing's going to be opening down, right? Whatever this thing looks like, it's going to be opening down, right? We're trying to find the highest point right there. Okay, so this opens down. Well, where's this highest point happen? Where does it occur? And we say, well, of course it occurs at the vertex, right? Since this thing opens down, it's going to occur at the highest point. Okay, so let's find the height there. Well, the height there is going to be the y value. Okay, and the second question, how many feet had the ball traveled horizontally at this point, right? How far had we gone horizontally? So what's our x value right there? Okay, so we say, well, vertex occurs on my axis of symmetry. When I'm doing this from standard form, negative b over 2a is the axis of symmetry again when I'm doing this in standard form. So our b value is 4. Our a value is negative 0.1. I plug that in. say, aha, that's my vertex. Okay, so my vertex is at 20. Now I go back to the original equation. Negative 0.1 x squared plus 4x plus 0. Okay, I'm going to plug in the 20. Just go ahead and do this on your calculator if you want to. And your y value here ends up being 40. Okay, y ends up being 40. So your vertex is at 20, 20, comma 40 here, if you will. Okay. Now your y-intercepts are actually your projectile starting right here and here. If you were to find the x-intercepts, I'm sorry. Okay. So the question then is, well, what was the height of the ball? He said, well, the height of the ball must have been 40 feet at its highest point, right? We just had to find that vertex. Height of the ball, 40 feet at the highest point. How far did it go to get to that horizontally? Horizontally, it's only traveled 20 feet. Okay? All right. See you guys in class.